So in this circuit, we're gonna use this side of the two resistors in series, because on this side here there's no current, because there's no potential drop. So we are using the flow that goes on the series resistors. So first thing first, the resistance on this section, because it's in series, and we're just gonna add the 60 ohms plus the 40 ohms, and it's gonna give us 100 ohms. And then we're gonna use, in question A, they are asking us what is the charge of the capacitor. We know the charge of the capacitor is gonna be C capacitor multiplied by V. But first we have to find what's the V. So we know that V is going to be equal amp multiplied by the resistance, the equivalent resistance. So V, that's 100 volt, equal amp multiplied by the resistance, and that's 100 ohms. And we are just going to divide them together. The current is going to give us 1 amp. And then we're going to use the volt of the battery is going to be equal of the volt of the capacitor. And the volt of the battery is 100. It's 100. Let me see, hold on. 100 ohm. Actually, this one. So the volt of the capacitor is going to be equal 1. Let's amp multiplied by the resistance, the total resistance. So the volt is going to be equal the resistance of the 40 ohms. That's where the flow is going to be the same flow of charge that goes through the 40 ohms resistor. So that's 1 amp multiplied by 40 ohms. And the volt of the capacitor is going to be equal 40 volts. And then we know that the charge is going to equal capacitance multiplied by volt. And the capacitance is 2 microfarad multiplied by 40 volts. So the charge is going to be equal 8 times 10 minus 5 coulomb. Going to number B. This question is a little bit tricky. Even the two resistors are in parallel, when the switch is closed, the switch is open at t0 second. At what time has the charge on the capacitor increased? So when the switch is open, the flow of charge is going through the 40 ohms and the 10 ohms. The capacitor will lose 10% from its initial value. The 40 ohms plus 10 ohms will be added, together. So resistance of the discharge is 50 ohms. And then we know that the charge is equal 0.1 multiplied by the initial value. The charge is going to be equal, I'm going to use this formula, tau, to measure the constant time, the time constant, which is going to do the resistance multiplied by the capacitance. And this is when we're going to use the 50 ohms multiplied by 2 microfarad, and the constant time is equal 1 multiplied by 10 minus 4 seconds. So this is 10% of the Q initial multiply. Actually, we're going to divide it by the initial. It's going to equal the integral of time divided by tau. That's, so this two will cancel. 0.1 equal integral minus time multiplied by 10 minus 4 seconds. So to eliminate the integral, we have to integrate from the other side, and that will equal minus 2.3 equal minus time divided by 1 multiplied by 10 power 4 second. So the time is equal 2.3 multiplied by 10 minus 4 second. This is the time that the charge will decrease by 10% from its initial value.